Listed below are systolic blood pressure measurements in millimeters of mercury obtained from the same woman. Find the regression equation letting the right arm blood pressure be the predictor X variable. Find the best predicted systolic blood pressure in the left arm given that the systolic blood pressure in the right arm is 85 millimeters of mercury. Use a significance level of 0.05. So we have this correlated data. We have some right arm values that correspond to left arm values. It would be best to use StatCrunch to determine this regression equation for us, so we will click the little box, open this in StatCrunch, and it gives us the data with the column headings already entered. Now we'll click Stat, Regression, Simple Linear, and it's asking us for which is the X variable. Well, the problem told us to use the right arm as the X variable, so we'll select right arm for X and left arm for Y. Click Next, and Next again. Now, we're supposed to predict a Y value for a given X value. And in the problem, it told us find out what the left arm pressure is when the right arm pressure is 85. So we'll enter 85 here. Now we may or may not use that value because we're going to have to determine whether or not we have a significant relationship first. So we'll click Next and Calculate. Now here then are the values for the slope coefficient and the y-intercept coefficient. We also have the correlation coefficient 0.8345. Now, if the correlation coefficient is greater than a critical value that we'll find on page 760 in the textbook, then we will determine that we have a significant relationship. Now let's see what the hypothesis test would look like. We'll test whether or not rho, the population correlation coefficient, is equal to 0. If rho is equal to 0, it means that there is no significant relationship. If rho is not 0, then it indicates that a relationship does exist. Now, the way we'll determine this is using the absolute value of the correlation coefficient. Now, this could be positive or negative. That's why we use the absolute value. If it is greater than a critical value that we will find in the table in the book, then we will reject the null hypothesis. Now, stating this then using that value, we'll go to the textbook and look on page 760. On this page, table A6, we find the critical values of the Pearson correlation coefficient R. We were told that alpha should be 0.05. Then we will find our sample size, so the number of correlated data values that we have, and from that determine our critical value. We had 5 sets of correlated data. So our critical value will be 0.878. So if the absolute value of R is greater than 0.878, we should reject the null hypothesis. R from StatCrunch gave us 0.8345. Now comparing that to this value 0.878, we would find that this is less. So our conclusion will be, do not reject the null hypothesis. Now in that case then, we can't use the value that was predicted by StatCrunch. When we put that 85 in there, it spit us back out here 153.6 as a predicted value of Y. But since we determined from our hypothesis test that there is not a significant relationship here, then our best predicted value is going to be the mean for the dependent variable. So what that means then is we'll go back to StatCrunch And we'll click Stat, Summary Statistics, Columns, Left arm, Calculate. Now our mean is 162.4. So that will be our best estimate then. For Y. Now, to answer these questions then, first we need to know what the regression equation is. And we have those values here. The intercept is 24.1 when we round to 1 decimal place, and the slope is 1.5. So we'll type in 24.1 and 1.5. Now it says, given that the systolic blood pressure in the right arm is 85, the best predicted systolic blood pressure in the left arm is, and again, we are going to use that value that we found for the mean, 162.4.